Hello, let's try another Leetcode problem 2811. So this is the second problem from the weekly test. Yeah, so basically we needed to split an array. So for example, this is what I did in the weekly contest. This is exactly the same code. Yeah, so we are giving nums, for example, 2, 3, 3, 2, and 3. So we need to split the array. So there are two steps. If we take out this 2, it is okay. What left is more than 6. So it means it is okay. So what is the next step? So we're gonna cut this is 3, for example. 3 is okay. What left behind? 3, 3, 2. The sum of them is 8. It is still okay. So what is the next step? So I'm gonna cut out from the 2, take out the 2, it is okay. And 3 is more than or equal to 6. So I'm gonna return true. Yeah. So this is my analyzing. I used this example in the contest. So what we're gonna do, try to solve this problem. Basically, we should use enumeration. So for the enumeration, it is a mathematical idea. Yeah, enumeration means we should take out the examples. For example, what about we just take one value? There's only one number inside. Yeah, if it is a 1, whether it is m equals to 6 or not, it doesn't matter. Yeah, because there's only one value. This one value is okay. It meets our conditions. We just take it out. It is okay. So what about there are two values inside? It is still okay. For example, 1, 2. We take this one out. Yeah, and we still have a 2. Yeah. So for the next step, we just take the 2 out. We don't need to use the second step, the sum of elements, yeah, of the subarray is greater than or equal to m. Because if we take this one out, it is only one number left. It is only one value left. It means we don't need to consider that. Yeah, the length of the subarray is 1. Yeah, it means this is one condition. If I take 1 out, the length of the subarray is 2. The subarray is 2, so the length of it is 1. I don't need to consider anything about it. So what about the subarray have three values? This is something we need to consider. This is what I call the enumeration. We need to enumerate by 1, 2, and 3. So what about 1, 2, and 3? And the m also equals to 6. Yeah, let's use this example. So it means no matter which number we take it out. For example, we can take out 3. It is 1, 2. 1, 2 plus 1 plus 2 is less than 6. So we're going to return false. So we can also take this 1 out. It is 2 and 3. 2 and 3 is less than 6. So we're going to return false. Yeah. So this is basically the idea how we going to approach this problem. If we have more numbers, finally, we're going to have 3 numbers. Yeah, but for these 3 numbers, it is always be the sum of the neighboring numbers. What I mean the neighboring numbers, it means 1, 2, and 2, 3. If all of them is less than 6, it means we cannot find. Yeah, I'm sorry. If it is the maximum, it's not all of them. If the maximum of them, it means we can choose any combinations. Take this 1 out or 3 out. Yeah. If the maximum is still less than 6, it means we cannot find the solution. We have to return false. If the maximum, yeah, is more than 6, the maximum I mean is 2 neighboring numbers. Yeah, it's more than 6. It means we can find a solution. Yeah, this is because if 2 neighboring numbers, the sum of them is more than 6. Yeah, we can also plus other numbers. For example, 2 and 3, if this 1, 2, I changed to, let me change this number 2 to 3. Yeah, if 3 and 3 is more than or equal to 6, no matter how many numbers we add, it should always be more than 6 because the numbers is always positive. Let's check the numbers, otherwise we cannot solve the problem. Yeah, so the numbers is positive. No matter how many ones we add, it doesn't matter. Because we can always delete it. We can take out one number, and the sum of them is always more than 6. So only the condition is this 3 and 3. So it means the maximum neighboring two numbers is more than or equal to 6. It means we should return true. Otherwise, we're going to return false. Yeah. So this result means the neighboring numbers. So nums I plus nums I minus 1 for I in raise 1 to n nums. So this means I will add all the neighboring numbers. For example, I will take this example, and what is my result? Should equal to, yeah, here I have this number. Yeah, here I have this number 2, 3, 3, 2, and 3. So what is the result? So this is my result array. It should be 5, 6, 5, and 5. So the maximum of it should be n. N is 6. So if this 6 is more than or equal to m equal to 6, so it means I'm going to return true. Otherwise, I'm going to return false. Yeah. Now let me submit it to check if it is okay. Yeah, but just because, yeah, let's just wait a while to check if it really works. At the same time, I will analyze the time complexity. The time complexity is still O(n) because this is a array. This is just one loop. It is O(n), and here the max it is also O(n). Yeah, it didn't increase any time complexity. As you can see, it's pretty fast because there's not so many submissions. It is 100%, but it is still okay. So this is basically the entire code. For this kind of solution, it is basically the mathematical idea of using enumeration and then generalization. Use enumeration to find out what should we do, and then use generalization to put a smaller number. We use the 3 numbers and then 4 and 5 numbers and then check which method we should use. Thank you for watching. If you think this is helpful, please like and subscribe. I will upload more Leetcode problems like this. See you.